Hey guys, Pankaj here. Welcome back. So from today onwards, I'm going to start machine learning video series. Okay, so we will be talking about complete machine learning, what it is, where we use, why we use, and what are the various algorithms in it. Okay, and what is the mathematical intuition behind each and every algorithm. So we'll see all the algorithm as well as a lot of examples and all the mathematical expressions also. So I may not derive mathematical expression, but we'll see what are the formula, what is their meaning, and how exactly it is used. Okay, so let me share the agenda of these video series. Then from next video onwards, I'll be uploading one by one each and every algorithm. Okay, so here is my PPT. Okay, I hope it is visible. Yes. Okay, so here is the agenda for this video series. Okay, so we'll see first what is machine learning, why machine learning, where machine learning fits into AI and deep learning. Okay, so this is very important, no, because nowadays we are hearing about AI, deep learning, ML, right? But how these are correlated, where exactly it fits. Okay, what are the types of machine learning, what are various tools and techniques to perform machine learning, which programming is more powerful to perform machine learning. This is also very important part because nowadays so many programming languages are existing right in the world. So you guys should be knowing very well like which programming is more powerful and which exactly to be used. Okay, and let's say you are choosing some programming language and you get stuck somewhere, right? And whether do we have enough support available or not, that's where this thing need to be decided first place. Okay, what are the various libraries for machine learning? What are the various steps to perform machine learning? What are the use cases of machine learning? This also we will see. Okay, what are common machine learning algorithms? So there are n number of algorithms, but what and all commonly used algorithm across all the data set? That's what we are going to focus on this video series. Okay, what kind of data we process in ML? So you will be hearing, or you would have already heard, like we normally process numerical data or maybe text data, image data, right? So what other data we process? So those things we'll see, and what kind of data we can process. Data is one thing, but what kind of data will be represented and whether this can be processed or not. If cannot, then how to convert or how to transform so that given data can be, or that raw data whatever is given to us can be transformed in a way that it can be processed by machine learning algorithm. Okay, so that's what we're going to see here. So whatever EDA part or exploratory data analysis part we have already done, if you have not done, then probably I would suggest go back to those videos and watch it, because almost all kind of data set and EDA part is going to be applicable in machine learning also. Okay, so let's say I'll pick up some raw data, and a lot of missing values will be there, and maybe some data needs to be transformed properly, which machine learning algorithm can only understand, right? So we have to do that. That is part of EDA. So complete EDA, right from data cleaning, transforming, everything we'll do once again. Okay, then we'll feed it to machine learning algorithm. Okay, and to SciKit, the one which is very heavily used, and this is so far one of the best library I have seen, very well documented, and what and all machine learning algorithm existing in the Python, and those are very powerful. Everything is very well documented with a lot of examples. Okay, so whenever I refer, so I would suggest to go with that link also, see more examples. I will take maybe one or two examples, right? But if you want to get deep dive into that particular machine learning algorithm and with more examples, go with SciKit and just have a look. Okay, it is going to give a lot of details. So what you will gain after completing ML videos. So once I prepare all the video, if you watch one by one everything, once you complete it, then what and all knowledge you would have gained after completing all the video. Okay, that also we are going to talk, and that is very important. And we'll see what are the minimum hardware requirement for machine learning model development. Okay, so because I think though it is last one, but this is something which you need to focus first, because before deciding or before started implementing machine learning algorithm, if you don't talk about this, or you don't put much focus on this, then one day you are going to stuck, because your PC may hang, or it is not supporting enough what to say process, or enough power it is not giving, where you can handle like very big data. Okay, large data, whether your PC is enough to handle what and all processing can be done by machine learning. Okay, so this is very important and we'll focus on that. So let's see first what is machine learning. Okay, so everyone is hearing nowadays, right? What so many products are coming out in the market, and maybe a lot of social media, a lot of projects are there, proof of concepts are there, which is based on machine learning. Okay, so we should know what is machine learning. Okay, so let me read about it. So machine learning is a branch of artificial intelligence and computer science which focuses on the use of data and algorithms to imitate the way, this line is very important, to imitate the way that humans learn, gradually improving its accuracy. Okay, so let's say if you go back 50 years back, right? So we were doing a lot of tasks and we were not having enough computer resource or hardware resource or software resource which we could have applied in that task and got it done automatically, correct? So nowadays we have it, but how to tell machine or how to tell computer, okay, this is what I am doing and you also supposed to do same thing, correct? So that's where this machine learning algorithm will come into picture. Using that, we are having some history of previous 50 years data. We are going to feed to computer and hey, this is what I'm going to do, and you should read the data or analyze data in such a way that you should be able to perform or very closely perform the action what human can do. Okay, so you should also able to do it. You means that I'm telling to computer. Okay, so that's where machine learning algorithm we are going to teach with the help of all the data. Okay, and later once it is done, then we will fine tune its accuracy so that it is more and more accurate like the way human does. Okay, so next is the machine learning algorithm build a model based on sample data. So I'll talk about one example here, then you'll understand. Based on sample data known as training data, in order to make predictions or decisions without being explicitly programmed to do so. Okay, so what exactly it means? Let's say I give a picture, right? Let's say some animal picture, and I just describe it has two legs and feather and two eyes, of course, one nose and one beak is there, right? So the moment I tell all the properties, you will immediately tell like I'm going to talk about the bird or I'm talking about the bird. Which bird I am yet to know that. Okay, but I'm just talking about the bird. Okay, so how you are about to tell like I'm talking about the bird? Because you have already have some picture or some you would have seen bird sometime back and you know the property of that bird, right? It will have a feather, two legs and beak, eyes, nose, correct? So that's where you are able to identify I'm talking about which particular animal or bird. But does computer know about this? No, right? We have to tell computer this is the property of my data. You also have a look, completely memorize it. Then whenever I give another data to you, you should be able to analyze what kind of data I'm talking or what kind of object I'm referring to based on the data which we have already fed to the computer. Okay, that's what we are talking here. Machine learning algorithm builds a model. It is going to create a model basically. So you have a model, give the input and output will be your prediction or what and all you are going to get. Okay, so build a model based on sample data which I just talked, right? Two feather and two legs, eyes, nose, correct? And data, and that data is known as training data. So this is something which you already know, maybe based on the history or the one which we just collected right away or a few days back. So that is the data we are going to feed to the computer. Okay, in order to make the predictions or decision without being explicitly programmed to do so. So you have already given all the instruction. Now you don't have to tell computer, hey, this is what you should predict. Computer will predict on its own by whatever he has learned or whatever computer has learned so far based on the history or provided the data. Okay, next point is machine learning algorithm use historical data as input to predict new output values. Okay, so we also know, right? So why I'm telling history data, because let's say talk about the alphabet, right? You know this, if I write like this, you know it is A. How do you know? Because you have been reading this as A. It has two angled arrow like slanting line and one horizontal line in between, correct? That is representing as A only, right? So you have been taught based on the previous history or maybe right from day one when you started going to the school, correct? So that's how you memorize it, and the moment I write, you will recognize the character. The same thing we are going to feed to a computer also, all the historical data and whatever data we have. And that is very important. You should have good amount of data by which a computer can learn. Okay, so that's about what is machine learning. Now, why machine learning? So machine learning is important because it gives enterprises a view of trends in customer behavior and business operational patterns, as well as supports the development of new products. Many of today's leading companies such as Facebook, Google, Uber make machine learning a central part of their operation. Okay, so let me give one good example here. So I'm sure everyone would have used Ola, Uber cab, right? So nowadays you would have seen, right? Probably now you'll see better because now COVID curves are almost removed and everyone is going to office or wherever, right? So they need a cab, right? So when you start looking for the cab exactly, let's say at the peak time, So whatever is happening in the Ola or Uber, maybe there is algorithm running which predicts, okay, which already has the data of cab booking exactly at that time. Let's say 9 to 10 a.m. Right? So they know it is going to be booked heavily because that is very normal time or usual time for person to go to office, right? So this will be peak time, and they are surging the fare now. Why? Because very high demand, and they know that like we are going to get a lot of people in this particular timing. Okay, so they are already running this algorithm. They know this is going to peak time, so let's rise the fare. And that's how they are making the money. Correct. Now another example is, let's say if you watch YouTube videos, right? So they are playing a lot of ads. On what basis they are playing ads? So you might have searched about, let's say, food. So they know the history and they know the browsing history also. So based on that, algorithm will tell, okay, or they are going to recommend, okay, you are the food lover, right? So they are going to play some food related stuff, food related ads. Correct. If you are watching Netflix movies or Amazon Prime, so you keep watching some movies, and after that certain time, that algorithm will keep learning like what is your viewing pattern. Okay, so let's say you like horror movies or you like sci-fi movies, so they will know the pattern, and based on that they will start recommending you may like that. Correct. So you will see those history, based on that they will start predicting you may like this movie, you may like that music, based on the music, the way you hear, the kind of music you hear. So all the pattern will be keep storing, and based on that data and based on the history they start recommending it to the user. And that's where machine learning algorithm is coming into picture. Okay, that's why it is very important nowadays. No matter what work you do, machine learning will be very helpful in that. Okay, now let's see where machine learning fits into AI and deep learning. Okay, so if you see this right left side picture, we have artificial intelligence, machine learning, and deep learning. So if you see, artificial intelligence is a bigger umbrella. Okay, under that umbrella we have machine learning. So basically machine learning is the subset of artificial intelligence. Okay, similarly deep learning is the subset of machine learning, and it is superset of artificial intelligence. Okay, so if you know machine learning, then you can do deep learning. And there is a what to say, machine learning basically we normally use for where data is not less than not more than 100 MB or 200 MB. When you have very large data, that's where we start using deep learning. Okay, so there deep learning neural network and all will come into picture. Okay, so right side image is also very much similar, but here you can see machine learning is nothing but it is some part of AI. Okay, and deep learning is also some part of AI it is using. Okay, but it is, you see, it is very much using machine learning. Without that you cannot do deep learning. Okay, so that's how it is fitting into AI. So now let's talk about what are the types of machine learning. Okay, so one of the simplest form is you have been given data which could be your supervised. I'll talk about what is supervised, and we have unsupervised learning, and we have reinforced learning. Okay, so let's see what supervised learning is. So we have something called task driven or predict next value. Okay, so here I will tell you, let's say I have 0 0, when let's say two numbers are there 0 0, and I'll give the target value, let's predict as 0. If you see somewhere all zeros, predict 0. If you see all ones, predict 1. Okay, so I'm just giving the label. Let's say you have, first of all you should understand what are the features, right? So features are nothing but it's one of the category where you are collecting the data. Let's say name of a person is nothing but feature. Age is nothing but another feature of a person, where you are collecting the age of all the persons. Okay, similarly their gender and their, let's say, salary, which company they work, what is their what is it, drawn salary, all the details. So those whatever category I'm talking about, name, age, gender, salary, company, all are nothing but a feature. Okay, so if I know a person whose age is, let's say, 20, and let's say he is just earning $1,000 per month, correct, and he belongs to, let's say, some city, correct. So I can give some category, or I can set some target, or what is it, I can give that label to the person. If you find any person who is having these kind of if their age is belonging to this and salary is between this range and their city is in this particular city, they must be having this particular level, let's say super intelligent, just for example. Okay, so I'm just giving the label, that is nothing but a target label. Okay, similarly if you give any other person name and this is, let's say, dumb, some kind of labels. So based on that, I'm just giving a data, putting the label to the machine. When they see this kind of data, right, they should be able to identify, okay, I'm going to get this data and if it is matching whatever I have as a history data or already loaded data or already trained data, I should be labeling as that person into this category. Okay, so that kind of thing will come under supervised, because whatever data you have, it is properly labeled. So let's talk about animal name, right? So we all the four legs and four legs animal, they let's say they are canine, so they will be, let's say, category as a let's say dog. Okay, all two legs and feather, they will categorize as bird. Correct. So similarly, if any data comes as a feature which computer has not seen, so let's say I'm feeding the data, okay, this is another animal who is having four legs. Okay, so how there, what kind of label it is going to predict? So we have already given the data, right? Any four leg, you just identify the, let's say, some animal, let's say dog. Okay, any next data which is coming and let's say it has feather and two legs, just identify as a bird. Okay, so that's how computer learns based on the label data, and that part comes under supervised. Okay, unsupervised learning, so you have similar kind of data but there's no label. Okay, so you have to do some kind of clustering or grouping together based on the learning, based on the history. Okay, that comes under supervised, unsupervised learning. So we'll see all the data, what kind of algorithm you can define under using for unsupervised, what kind of algorithm you can use, for supervised, what algorithm you can use. Okay, and under supervised also we have two kind of categories: categorical value data and linear value, discrete value, continuous value. For that we have linear regression. We'll see all those things. Now for reinforcement, so learn from the mistake. Okay, so here also we have data, it could be, let's say, mix of things, and let's say best example is self-driving car, right? So you never know how to drive, right? So we will give some instruction, this is the way you should drive. If something is broken, then you should learn from that broken thing or the mistake you have made. Okay, and next time you improvise your, you improve your algorithm in such a way that you always drive properly. Okay, that is for self-driving car. Similarly for game, while crossing the different levels, if you have not crossed the level, what mistake you did, learn from the mistake and try to cross the next level. Okay, so those kind of algorithm is nothing but reinforced learning. Okay, so some detailed forms. So again, machine learning types, we have supervised, under supervised we have regression and classification. We'll see what is regression, where you see a lot of discrete value and a lot of continuous value, you will be using regression. If we have category, let's say category I'm telling, right, let's say dog, cat, or maybe some bird, correct? So those kind of comes under classification. Okay, then we will have unsupervised learning, clustering. So you have the data but there is no label, so you group them together. Okay, so let's say there is a news feed. Okay, so a lot of news feeds are coming and you never know this news belongs to, let's say, sports category, or maybe politics category, or maybe, let's say, IT sector or stock market, correct? So you never know. So based on the news, we will be giving some training to the computer, make sure that if you see this kind of politician talking, see this word and that word, then you categorize that as a politics. They're talking about the sports, then categorize as sports. So that's how they will do the clustering. Okay, so we'll see what kind of algorithm we can do. So another example, like product customer segmentation. Okay, then we have semi-supervised, where data will be there, you may have label, you may not have. Okay, so that also comes under clustering and classification. Something related to speech analysis, like speech is related to what, again, politics, news, or whatever. So in reinforcement learning, there we have classification and control, and self-driving car is the another example. Okay, so we'll see a lot of algorithm which belongs to either supervised, unsupervised, semi-supervised, or reinforcement learning. Okay, and what are various parameters and how to tune them, how to train the data, how to predict the data. In every algorithm, I'm going to show all the examples along with their mathematical intuition. Okay. Now let's see what are the type of machine learning. Okay, in detail. So what is supervised learning? In this type of machine learning, data scientists apply algorithms with the labeled training data. As I mentioned, right? You have the data with their labels also. Data and define the variables they want to algorithm. They want the algorithm to assess for correlations. They'll find some relation or correlation, and based on that, whenever future value is given to the computer, they are going to predict it. Okay, so both the input and the output of the algorithm is specified. Under unsupervised learning, this type of machine learning involves algorithms that train on unlabeled data. You have given the data, but there is no label, what to predict. That's where you will do some kind of grouping based on the history, or based on the experience, Okay. The algorithm scans through data sets looking for any meaningful connections. The data that algorithm train on train on, as well as the predictions or recommendations they output are predetermined. Okay. Now let's talk about semi-supervised learning. This approach to machine learning involves a mix of the two preceding types. Means you have the data where some of the data will have the label, some of the data may not have the label. Okay, that is what it is. A mix of both above whatever we have talked about it. Data scientists may feed an algorithm mostly labeled training data, but the model is free to explore the data on its own and develop its own understanding of the data set. So what you filter out the data where labels are there, feed the data, and whenever you give the data where labels are not there, give it to computer or give it to your machine learning model, and based on the learning whatever it has done so far, accordingly it will predict the label of that unseen data. Okay. Now, what is reinforcement learning? Data scientists typically use reinforcement learning to teach a machine to complete a multi-step process for which there are clearly defined rules. Let's talk about the game or self-driving, right? A lot of rules will be there. Data scientists program an algorithm to complete a task and give it a positive or negative cues as it works out how to complete a task. Okay. But for the most part, the algorithm decides on its own what steps to take along the way, because it would have already learned from the mistake what it has done on its own. That is what is reinforcement learning. Okay. Now let's see what are the various tools and techniques to perform machine learning. Okay. So 10 most popular machine learning software tools comparison chart that is here. So one of the best one, and that is what I'm going to focus more on, is SciKit Learn. Okay, it is freely available tool in Python or library. Okay, in Python library, and you can just, so you have already loaded Anaconda, right? So this is available. So we'll just have tour also about this website, and we'll see how to proceed further. Okay. PyTorch, another library. TensorFlow is also very heavily used. This is also used for deep learning and all. Okay, and this is developed by Google, so you don't have to worry. Good support is there. If you face any problem, go to Google and you will get the support. Okay, and very good documentation also there. I think PyTorch is developed by Facebook, so here also we have good support. Then we have Orange. So Orange is basically graphical user interface. With the help of, you just drag and drop the block and feed the data, get the output. You don't have to do any coding. Everything will be done in the background. So I'll make a separate video on Orange also. It is very good for those who are learning and exploring as a beginner. Okay, for the machine learning, statistics, text analytics, speech analysis, whatever field you're going to work on. So Orange is very powerful tool. I'll show that. Okay, we have Weka, Naim, Colab, Apache, Mahat, Ecor.net, Shogun, Keras. Keras is also another library. So I think once I talk about deep learning or AI, right, I'll be using Keras also. TensorFlow or Keras. And RapidMiner. These are some tools, but whatever is highlighted in yellow, right, those are the ones which you are going to focus on this machine learning video series. Okay. Now let's see which programming language is more powerful to perform ML. Okay, so I have given the link here just for your reference. And if you see the chart, right, so one of the best language is nothing but Python, which is already picked up so fast. You see here the graph. See how fast it is trending. A lot of other languages are also there way back to, I think, 1988. But see, their graph is declining. And you see dark, what do you say? Which color? I think dark red. Okay. So it used to be maybe bottom 10 where in 1998, but now you see in 2018. So this is almost 2-3 years back data. Okay, now if you take the latest, it has already surpassed Java and C++ also. It is on the top. Okay, this is some old data, but you can just Google it once again and Python will be on the top. Okay, and use Google searches for coding language. So the person whoever is searching the which coding language to be used, right, Python is the most commonly used. You see here, Java used to be on top by 2010, and 2018 it has come down to almost 60, their ranking. And you see here, Python. Okay, see the trend. Python is picking up the fight. It has already picked up fast. Okay, guys, so now you know which language to decide. Okay, so those who are still having dilemma where to choose Java, Python, R, or whatever, stick to Python. And that is really going to be very helpful for you guys. And almost all the industries are talking about Python only, and they are using Python because one of the best reason is it is freely available. That is one thing. They don't have to pay any single penny for this. Another is very good support. you don't have to really struggle for getting answer for any problem. N number of resources are there which will help, which will have all the answers for whatever query you are putting in Google. Okay. Now let's see the next one. Yeah, what are the various libraries for machine learning? Okay, so machine learning, yeah, NumPy we have already seen. Why NumPy? Because all the data, what machine learning understand, it should be basically a numerical data. So no matter you have image, it has to be converted to numerical. That is nothing but using OpenCV or reading image in the form of multi-dimensional array. Okay, if you are having text data, text also to be converted to number, which we'll see in the text when I think I'm going to make a couple of videos how to do bag of word conversion, word to vec, all those things, because machine learning will not understand anything related to text you convert to number, how to convert, which will show in which we'll see in the future videos. Then you feed that number to the machine learning, and accordingly it is going to predict the data, text data. Okay, so we have already seen NumPy, NLTK, Spacey, right? Those things are going to be helpful. SciPy, again, is if you are going to use some statistical methods under SciPy, you can use that. We have already seen under statistical video, right? SciKit the one which we are going to focus from now on. Theano, TensorFlow. I'm not going to use Theano, but it is also there. Those who want to explore it later, they can use it. TensorFlow we will use in some video once we talk about deep learning. Keras also I'll use. PyTorch I may or may not. But Pandas, Matplotlib we have already used, right? For creating data frame, reading the data into data frame, and converting data frame into .html, .csv, .sdf5, whatever format you want to save it. Okay. So those are the library which is freely available. It is already loaded in Anaconda. So you are good to start. Okay, what are the various steps to perform in machine learning? Okay, so here is the data collection. That is the first part, which we have already done under EDA part. Either you are getting the data from someone or you are collecting through social media or maybe any other platform. Correct? Then data preparation. So you need to have certain, you need to have data in a way that which can be understood by the Python program. So maybe let's say you're talking about data frame, you have to convert into data frame. Okay, that is what under data preparation. Then data cleaning, EDA part, filling the missing values, removing NaN, all those things will come under data preparation or data cleaning, which we have already seen. However, while using example for machine learning, I'm going to repeat those process. Okay, then choose a model. So how to choose? So as I mentioned, right, what kind of data you have, whether it is labeled data or non-labeled data. So for labeled data, we'll go with supervised learning. For non-labeled data, we'll go with unsupervised learning. Okay, then based on that, we can choose the right model. Then we will do the training and testing. So first we'll do the train the model. So basically training model is nothing but you have got the data, you're feeding it to algorithm. Now algorithm will start learning, or we are training, or basically model is getting trained. Okay. So after the training, we have to do evaluation of the model. Okay, so evaluate the model means basically first you will predict it, and whether prediction is really right or it is having some bias, some deviation is there. So you have some kind of evaluation matrix. We'll see a lot of metrics are there, which I'm going to talk from maybe next video onwards. Okay, so we will evaluate and what is their accuracy. Okay, whether you are getting accuracy as 30% or 95% or 99% or 100%. So all those things will come under evaluating the model. Then parameter tuning. So we need to tune the parameter also. Let's say you are getting accuracy very less. You need to tune to perform the accuracy better, right? To get the accuracy better. That will come under parameter tuning. Then make predictions. So this cycle will keep going on until you get the desired data. Okay. And here also this is a life cycle: getting the data, data preparation, data wrangling, basically nothing but data cleaning and wrangling. All those things come under this. Okay, analyze the data, train the model, test model. Test model is nothing but basically prediction. Okay, and evaluated model. Then deployment. Okay, so we'll see deployment also once all the algorithms are covered. Now let's see what are the use cases of machine learning. Okay, so let me read about this. So advancement in AI for applications like natural language processing, NLP, and computer vision are helping industries like financial services, healthcare, and automotive accelerate innovation, improve customer experience, and reduce cost. Machine learning has application in all types of industries, including manufacturing, retail, healthcare. You just name it, it will keep coming. Okay, so no matter nowadays, no matter which domain you are in, everywhere machine learning is there. Earlier it used to be like finance and stock market and healthcare and all, and retail especially. Retail and finance was the very heavily used machine learning algorithm. Okay, but nowadays no matter which domain, everywhere it is used. Travel and hospitality, financial services and energy, feed, stock and utilities. Use case include manufacturing where predictive maintenance and condition monitoring. Okay, retail upselling and cross channel marketing. So retail also it is very useful because they will be using like what kind of product customers are buying. Okay, when they buy something, what else they buy along with that particular product. Okay, so they should capture all those data. Based on that, they can fine tune their marketing strategy or the way they are listing the product, right? So all those things will come under retail. Healthcare and life sciences, the disease identification, disease satisfaction. So there, especially artificial neural network, convolutional neural network, all those things are heavily used because a lot of diseases, right? They will be using X-ray, whatever scanning they do, right? So just feed to the data or model and see whether what disease they are having. They can predict it, whether they are cancerous, non-cancerous. All those things will come under healthcare and life sciences machine learning model. Travel and hospitality, dynamic pricing I talked about, Ola and Uber, right? So similarly in travel and hospitality also it will come. Okay, financial services like risk analysis and regulation, energy demand and supply optimization. These are like not only limited to this, but there are so many other sectors. But these sectors are heavily using machine learning. Okay, so what are the common machine learning algorithms which we are going to learn in this video series? Okay, so here is the list of commonly used machine learning algorithms. These algorithms can be applied to almost any kind of data problem. Okay, so first and foremost algorithm and basic one is linear regression. So the next video will be based on linear regression. We'll see uh, very soon. Then we'll see logistic regression. Then what is the mathematical intuition behind linear regression and logistic regression? Not only on these two, all the algorithm whatever I've listed, I am going to explain all the mathematical intuition, their formula, everything there. Okay, how to fine tune. If any problem is there, then how to resolve the problem. Okay, then we'll see decision tree, support vector machine, naive Bayes, KNN, K means. Okay, the KNN is nothing but K nearest neighbor. Okay, naive Bayes, this is very heavily used in text analytics, text prediction, spam classifier, all those things. Okay, then we have random forest dimensionality reduction algorithm. That is nothing but like PCA, principal component analysis. We'll see what is the mathematical intuition, how it does. But this is one of the best algorithm for dimensionality reduction algorithm. Then we'll see gradient boosting algorithm. We have gradient boosting algorithm, GBM, XGBoost, Light GBM, Cat Boost. All those algorithms we'll see and see how fast they do the prediction and how best they provide the accuracy of the model. Okay, so everything we'll see with a lot of examples. What kind of data we process in ML? I already talked, right? We have numerical data. It could be discrete. It could be continuous. So discrete means just as a number. Okay, there's no decimal point. Continuous means you will have 23.45, 1.16, something like that. Okay, so discrete numbers are units, whole number, language spoken, number of students, like that. For continuous number, you will have decimal point also, like let's say between 1 and 2. There could be infinite number, right? Infinite possible number between 1 and 2. That is nothing but continuous number. Okay. And then we have categorical data. So categorical data is nothing but, let's say I told, right, we will have given the label, and label could be, let's say it's a dog, it's a bird, those kind of categories, correct? Where let's say super active, non-active, those kind of coming under category. Okay. So here some data is there, like it's a beginner, intermediate, advanced, right? So those are nothing but putting the category for, let's say 1 star is nothing but beginner, 2 star nothing but represents as intermediate, 3 star is nothing but advanced. Yes, those are nothing but categories. Then we have time series data also. Let's say stock market, temperature. Okay, so all those things comes under time series. Then text data, we have already seen under EDA part, right? No, not EDA, basically NLTK and SPACY. So we talked about text data, right? So there also we'll be running machine learning algorithm. These are the possible kind of data which you may get to solve the machine learning problem. Okay. Then we do have image also, but image is nothing but your numerical data. It's a multi-dimensional NumPy array. That's why I have not listed separately, but it comes under numerical data. Okay, so and if you talk about the speech also, speech is nothing but it's a signal, and that signal will be nothing but a lot of variations, and that variation is nothing but amplitude of the signal, and that is again a numerical data. Okay, so speech and image, all those things will come under numerical. Test is separate data which must be, or ultimately it will be converted to number. Okay, so all will boil down to your numerical data only at the end, before going or before proceeding for the algorithm, machine learning algorithm. Okay, let's see the next one. So we'll see what are the types of various types of regression. The first is linear regression, which we are going to see in the next video. Then what is polynomial regression, support vector regression, decision tree regression, random forest regression. So when I say regression, means they are talking about numerical value. Okay, and when they say linear classification, polynomial classification, or support vector classification, correct? So those are nothing but they are talking about the categorical data, because there you cannot run linear regression. There it must be classification, whether they belong to dog, or they belong to cat, or they are belonging to a specific bird category. But in regression, we are talking about what is your next value. It could be discrete, it could be a continuous value also. Okay, so remember, first you should understand what is the difference between regression and classification. Anyway, I'm going to talk about this again in the next video. Then we have ridge regression, lasso regression, then logistic regression. Okay, so to SciKit, so I'll show this link also. And so what is SciKit learn basically? So formerly it was known as scikits.learn and also known as sklearn. Okay, so most frequently they use as sklearn. Is a free software machine learning library for the Python programming language. It features various classification and regression and clustering algorithms, including support vector machines, random forest, gradient boosting, k-means, and dbScan, and is designed to interoperate with the Python numerical and scientific libraries NumPy and SciPy, which we have already seen. These are the things which we are going to see. Okay, where it is? Yeah, whatever algorithm they mentioned, right? Like regression, clustering, and support vector machine, random forest, dbScan. Those things we are going to learn with the help of NumPy and SciPy. Okay. Now, let me talk about what you will gain after completing all ML videos. Whatever video I'm going to make, once you complete all, you have done all the exercise and everything you're going to do in parallel. What at the end of completing all the video, what you're going to learn basically, and what kind of knowledge you will have. Okay, so you should be able to perform EDA on any kind of data set. That is one thing which we have already seen, but we are going to see again while applying machine learning algorithm. Okay. Then we have data cleaning and data imputation, which is again part of the EDA. Then choose right ML model. So now your data is ready for feeding it to machine learning algorithm. Okay, so which model to choose, whether it is supervised, unsupervised, or reinforcement based on the data, whether to put for regression or put for classification. So it all depends on what data you have, what kind of data you have. Fine tune a machine learning model. So once we generate the model, we have to fine tune also to increase the accuracy. Predict the values or category. So value is basically regression, but category is nothing but classification. Increase model accuracy. How to increase the model accuracy? You will be able to understand this. Understand underfitting and overfitting. Okay, so whether your model is giving always high accuracy, it is means overfitting. Whether it is underfitting, it is working only for few data but not for all, right? So it is underfitting. So we'll see this kind of problem where we will get and how to overcome from this problem. Okay, use various performance measurement metrics and model evaluation. So you will be able to do your model evaluation by different measurement metrics, which is available in sklearn. You will be able to save the model, you will be able to load the model. So why this is required? Because you have done all the training and testing, right? Now, whenever you get next data, do you need to do again training testing? No, you need to save the model. Just give the new data, which is not seen by your machine learning algorithm. Give it to model will give you the predicted output. Okay, that's what is saving and loading the model. Deploy model in Heroku or Google Cloud Platform. This also we'll see once completed all the algorithm. Okay, develop a small application based on any ML algorithm. We'll see one of the application will pick up and just develop some using some ML algorithm, and we'll do end-to-end development. Okay, what are interview questions that can be asked for each ML algorithm? So whenever I start talking about linear, then logistic regression, whatever algorithm I'm going to talk, and then I'm going to talk about some interview question which is more focused on interview. Okay, so that also you will get to know, and in every notebook I'm going to mention that. Okay, so what is the minimum hardware requirement for machine learning model deployment? Okay, or development. So first we have RAM, 16 GB RAM you should have. CPU should be Core i7, and storage should be 500 GB or at least 1 TB. OS it could be any. So Ubuntu 20.04, that is latest one, Windows 10 or Mac. Okay, and cloud-based, if you want to do, if you want to use it, then Google could have a Kaggle platform. So I'll show later once at least we have completed a couple of algorithms. Okay, how to use Google Colab or how to use Kaggle platform. Okay, so those are the minimum requirement. Now let's go ahead and talk about SciKit. So I'm just going to open SciKit. Not this one. sklearn. Yeah, just look for sklearn and go to the sklearn.org. Okay, so once you go to this particular, I think I'm not sharing, so let me just go back. Okay, so go to sklearn.org and here you will get all the algorithm details. Okay, just go to user guide. This is very important. Okay, so just follow this sequence: supervised learning, unsupervised learning, then model-based selection, evaluation is what we are also going to follow in our video. Okay, so it has all the details with complete mathematical intuition about the model with a lot of examples, and notebooks are also there. You can just download and run it. Okay, so but before that you should start watching the video and understand what is their mathematical intuition, how it works with simple data set, then you apply on whatever data set you want. Okay, so that's what we are going to see. So at least you start reading about this, you will understand. You should get familiar with sklearn first, then it will be, your job will be easy to learn machine learning very quickly. Okay guys, so yeah, that's all I wanted to show you guys. This was the introductory session. So I'm sure you are quite interested for starting with first linear regression model, how to work on it, and what are various interview questions, what kind of things will be asked, and what kind of data set to apply. We'll all see, and we'll have fun while learning. Okay, you'll get to know a lot of internal details about machine learning algorithm, and I'm going to explain in a very easy way so you can easily learn. Okay, believe me, whatever you have learned so far, machine learning will be quite easy than what you saw in earlier videos. Okay, just 3 lines of code, your machine learning model is ready. That's all. Give the data, predict the output. Done. 4 lines of code. Later, it's art of tuning the data so that your accuracy is improved. That's what we are going to see. Okay, guys. So that's all from my side. And those who have not subscribed my channel, please do subscribe. Click on notification button so that you guys can get the notification whenever I upload new video. Okay. Thank you so much and have a good day. See you in the next video. Bye-bye.